Today we're talking about 3.2, continuing with our exponential functions. We go into logarithms today. And you might ask yourself, what is a logarithm? What are they there? And you might have seen logarithms before, and you might have asked yourself, what exactly is a logarithm? So let's go into a simple example. We know for sure 5 squared must equal 25. Well, the logarithm says, well, the log, our base is always going to be what? 5. The log of 5, so say with this base, and we want our answer to be 25, how many times do we have to multiply 5 by itself to get 25? Well, then our answer is 2. So basically, logarithms are there to try to help us find the exponent needed to find the answer. So that is, let's do another example, okay? A different one. So let's say we have a log of 5 to the 1, 2, 215 equals -3. We're like, oh, okay. So how could we rewrite this as an exponential function? Well, we would say 5 to the -3rd, because that's our exponent, should equal 1 over 125. Exactly like that. Let's try to solve some others. So let's say we have a log of let's say 16, and we don't know what value it is, right? But let's say we want to say, well, what if our value, our x, is say 4? There isn't an easy way on your calculator, so this isn't a way that you can easy way to put on your calculator to find what is the 4. So basically, we want to find log 16 of 4. What this is basically what we want, saying basically too much. Let's call this value a, and then say, okay, 16 to what power, we'll call that a, should equal 4, just like that. Well, I know some things, right? I know to get from 16 to 4, isn't 4 the square root of 16? And square roots can be said the same thing as 1/2. So if you put anything to, say, 16, and you put the little caret on your calculator to the 1/2, that's the same thing as saying the square root of 16. So this, I know to get the square root of 16, we get 4. So a here must equal 1/2. What if we got an equation that didn't have a base, right? Let's just say we have a log of 1,000. Well, luckily for us, we can just use our calculator, punch that in, put in that. It should give us the answer as 3. Let's do another example. Let's say we have a log base of 6 of x, and x equals 1. Well, that means they want the log 6 of 1. Well, what they're saying is 6 to what power, right? 6 to whatever power, I'm going to call that a, it must equal 1. Well, we know that anything to the 0 power must equal 1. So then a must then equal 0. Let's continue with our examples. So what if we had a log a of x, and they say, well, x here is equals a to -5th. Well, what they're basically saying, our base a to what power? I'm going to give this another value, Okay, I'm going to say y here. To the power of y must equal a to the negative fifth. Well, that's not so bad. Well, we know that y must then equal negative 5. Continuing with more examples, what if we had a log, and if they don't put in a base, assume 10. When there is no base, it's always going to be 10. That's what is always in your calculator. When you put the log, punch in log of something, the base is always 10. So let's say we have log of x squared equals the log of 27. Well, we can cancel out our logs here. This, we can cancel our logs to solve. And then this becomes an easy quadratic where you can just factor like so. 2 factors of 27 makes 3, 9 and 3, right? 9, 3, positive 9, negative 3. Our answers must be negative 9 and positive 3. Let's go on to natural log and exponents now. In this case, natural logs and exponents can be considered like opposites of each other. So if we were given the natural log of 1 equals 0, well, then we can inversely say the e of 0 must equal 1. Exactly like that. So if we were given e to the negative, let's say 1/2, must equal 0.6065. Well, inversely, so we can say negative 1/2 equals the natural log of 0.6065, like so. And since they are inverses of each other, anything one within the other, just like before, when we found our inverses, the slope of them is always 1. So if you put 1 inside the other, they will always equal 1. So e to the natural log of, let's say, x is going to equal x. They really reduce each other out. So let's do an example. So let's say we have a natural log of 1 over e to the 5th power. Well, we know what the natural log of e is from up here. So how can we rewrite this? Well, isn't e to the 5th power 1 over that? Isn't that e to the negative 5th power? Because you can just take it to the top by having the negative exponent, or down to the bottom to turn it back to the positive. Well, then they kind of reduce each other out, and so then this just becomes negative 5, just like that.